A black hole. It is the most mysterious thing we have ever known until now. They have the most powerful gravity. They are so massive that they can bend light and slow time. They are scary and can eat anything coming in their way. Nothing escapes them, not even the light. Yes, they are the real monsters of the universe. Hello everyone and welcome to Cosmoscience. In this episode, we are going to learn about the black holes. A black hole is the region of space-time where in a very small space so much matter is crushed that the density of that area becomes infinite and the escape velocity becomes more than the speed of light. Anything going in doesn't come out of a black hole, so they are completely black. You just can't see them. We have very limited understanding of these giant eaters. A black hole is born when a massive star that is almost 20 times more massive than our sun runs out of its fuel. It blows out in a huge explosion called supernova. It leaves behind the core of the dead star. Now this core suffers a gravitational collapse in which the gravity wins over all the other forces within the core and squeezes all the mass of the core into a million times smaller space, creating a monster, a black hole. Let's check out the anatomy of a black hole to understand it. The singularity. It is the centermost region of the black hole where all the mass is concentrated. It has infinite density and gravity and looks completely black. Hard to understand, and the laws of physics just don't work over here. The event horizon. It is the last boundary for a safe orbit around a black hole. If you cross this line, you are gone forever. There is no turning back from here. Photonosphere. It is the most brightest part of a black hole. The supercharged particles give off radiation, forming a ring around the black hole. Generally, a feeding black hole has lots of dust and gas around it. Due to the friction and acceleration among the particles, they become superheated, forming plasma. This is seen in the form of a disk known as accretion disk. Relativistic jets. These jets coming out of the poles of the black hole are present only in feeding black holes. These can extend up to millions of light years and form due to the magnetic field generated by the accretion disk. They contain superheated plasma and anything coming in their way is demolished. Now question arises, how do astronomers detect a black hole when it doesn't radiate out anything? That means it's completely black. Well, the truth is, a black hole can't be seen by direct observation. Scientists look for indirect evidence to confirm the presence of a black hole. They are looked for two of their most prominent features. Number one is huge amount of radiation and the other one is their gravitational influence on the surroundings. Let us watch what happens when an inactive black hole comes closer to a star. The gas from the star forms the accretion disk around the black hole. The charged particles in the disk produce magnetic field, giving off X-ray radiation. Now this X-ray radiation can be detected with the help of our X-ray telescopes. On the other hand, the gravitational influence of the black hole causes stars to go in an orbit around it. It normally looks like a large number of stars orbiting a very small and invisible mass, and nothing known cosmological body so massive is known to exist other than the black hole. Meet you in the next episode. Till then, happy stargazing.